We as a company design and run feasibility on a whole range of imaging and sensing technologies. The challenge came to us through the KTN IX project. This challenge of detecting liquor and solids in pipes and vessels, it struck us we could directly address. So the system's pretty compact. We've designed it so that it fits very nicely into a 5.5-inch aperture. The system's designed to have a polycarbonate gaiter put around it so that it's completely airtight, but we've been very careful to keep the weight under 20 kilos. The detector and any electronics associated with it has been made rad hard. The most complex deployment scenario is through an access port into a hot cell. It emits X-rays out in a pencil beam at an angle of 17.5 degrees, and because of the pencil beam nature of the emission, we can get both depth and spatial information. So we can very easily detect whether this is liquid, solid, and especially high Z materials and obviously active materials. They show up really strongly on the detector.
Compared to conventional techniques, Unitive's technology gives us potentially the opportunity to do that inspection without close contact with access from just one side, compared to something like ultrasonic inspection, which relies on that close contact.
It can be attached to anything. It can be attached to a gantry that rotates around pipes. It can be clamped to a track, and it can also be deployed on jacks or vertical gantries. The whole system has been designed to be completely modular. It's an extremely flexible system. We took the approach of taking off-the-shelf and commercially off-the-shelf products and putting those together in such a way that we could absolutely maximize the detection ability for liquors and solids. The detectors are absolutely state-of-the-art, so we can get rid of unwanted or scattered radiation that we don't think is part of the image, and that gives us a better, more accurate and lower noise measurement of what's inside that pipe. We can detect 1 millimeter of water or even less in stainless steel pipes which have got a 2 millimeter wall thickness. We increase that wall thickness to say 10 millimeters, then our limit of detection increases to about 2 or 3 millimeters of water. Detecting water through stainless steel objects with a 10 millimeter wall thickness is pretty impressive. What we've done is really optimize the system for detectability. This is about really getting the lowest limit of detection out of the system and therefore making it most useful to the application. And the application that we're targeting is really that detection of very small quantities of liquor and solids in these pipes. The other half of the system is of course the software. It's able to give you information about material, it's able to give you information about wall thickness, it can give you information about the size of the vessels and how far away you are. And it's this aspect of the software which is incredibly powerful and the thing that's really going to address the challenge of determining how much liquor or solid is in a pipe. We've developed this and qualified it so that you can have complete confidence in the information that you get back from the system.
What we've seen so far is very encouraging, and we're hoping that we'll be able to take this project forward.
All of our history as a company and individuals in working in designing imaging systems, in designing specifically X-ray imaging systems. So all of these are kind of the pieces in the puzzle that when we saw the challenge, we realized that we had many of the pieces. It was very exciting for us to see what we could translate, ultimately taking it into a test facility, putting a pipe there with some water, switching the system on and going, oh wow, okay, actually, it really works. It doesn't just work on paper.